Here's note 4. From the first line, it's in slope-intercept form, I can pull out a slope. I can say the slope is 1/2, and a nice point of 0, 3. I'll graph that. So as I move down to my graph, it tells me to go 0, 3 as my starting point. I follow the slope. The slope is telling me to go up 1, right 2, up 1, right 2, up 1, right 2. As you put a series of these points on here, you also want to balance it, so you want to go the other direction, which would be down 1, left 2, down 1, left 2, down 1, left 2. It should be enough that I can connect the points. There's my line. I go to the second equation. Because it's in standard form, I have to take A over B, change the sign. So the slope will be 1 over 2. And because there's a negative here, I know my slope needs to be positive. Before I go any farther, as I look at this, I notice that both slopes are 1/2. This guarantees that either the lines are going to be parallel or it will be the same line. And so I need to find a nice starting point to determine which result it will be. If I plug 0 in for x and I solve this, I get -4. So I put 0 in for x, I'm finding the y-intercept. I get -4 for my y. Now that tells me, as I graph this, I go down 1, 2, 3, 4 units, and it follows that same slope of up 1, right 2, up 1, right 2. My solution is pretty obvious. These lines are going to be parallel. They'll never intersect. And that's how I would write my answer. I'd write parallel, no solution. There is no point that they share in common. Again, how I knew that? When I looked at the slopes, there's one of two things that can happen. Either they're going to be parallel lines or they're the same line. So that was pretty obvious. We had parallel lines here. That was note 4.